Hey everyone, welcome to this 1 hour Python crash course. Whether you want to build AI agents, land a high paying job, create websites, automate tasks, or just make funny little programs, Python's the way to go for all of them. And the first step is mastering the fundamentals. By the end of this video, you'll understand all of the fundamentals of Python from setting it up to writing real programs. And before we dive in, if you want to go just beyond watching tutorials, I've got something for you. I run a free Python community at school.com/coder. The link right here. It'll also be in the description. And if you join, you'll get free coding challenges, exclusive workshops, more courses, boot camps, and direct support from other Python developers, including me. And it's completely free. So it's going to be the top link in the description if you're interested. To start off with, why would you choose Python? Well, Python's beginner friendly, in demand for jobs, and used in AI, automation, web development, and a lot of other industries. If you learn Python well, you can do almost anything from data science to game development to machine learning. It's also a great beginner language to learn because it's pretty simple to pick up a lot of concepts on compared to other programming languages. You can then, if you want to learn other programming languages for different things, you can learn them a lot quicker because you're just translating your knowledge of Python into them. So the first step that I'm going to go over very briefly is setting up your environment. So first, you'll want to download Python from this website if it's not already installed. If you have a Mac computer or a Linux computer, it might already be installed. And in that community, I'll also link this in the description, but inside of the course I have on there, one of the courses, I have full detailed instructions on how to set up Python for whatever your environment is. So that could help. Or there's a lot of other resources online. Eventually, I'm going to go through a full breakdown where I install these and show you guys how to have a great setup with them. But go to this website for now, download, follow their instructions. If you need help, go to the community. You also will need a code editor. What this is this is basically where you write and run all of your code. And for beginners, I recommend using Visual Studio Code, which is made by Microsoft. It's really widely used. There's a lot of support for it. It's really simple and it's a good code editor. So I'll put the link for this also in the description. You just go here, download it, follow their installation process, and then you can get started. So after you have that installed, you're going to see a code editor like this. The first thing you'll want to do is open up a folder or open up a project. I already have one open, but just click open folder, make a new one, name it something like Intro to Python course, create a new folder, open it, trust the authors, and then you'll be like something like this. Like you'll see this welcome screen actually. So then from here, you want to go over here, make a new file. And for the first thing we're going to do, just to make sure everything's working, is you want to make a hello world.py file. A Hello World project is basically what the introduction that programmers do no matter what programming language they're learning or writing in. So basically what you do to write Hello World in Python is this. So it basically is just the simplest version of a program, and Hello World has been coined as just putting something in the terminal that says Hello World whenever you're able to. So write that code, Control S to save it, and then click this little play button up here to run the file. And you should see in your terminal, Hello World. I'm actually going to clear mine real quickly and run it again because I had one from before. But there you go, Hello World. And that means everything's working and everything's installed and you're ready to go on. The first topic I'm going to be covering in this is variables. Variables are data structures that can hold other data. So they're just very simple. Here's an example of variable, x equals 10. It's basically like algebra where you're solving for x, but you get to set what it is, and then you can use this for things. So before, as we saw, print just puts the stuff in the console. So if we print this out, you're going to see it prints out the value of 10 because x is actually holding the value of 10. And this is really powerful because you can actually manipulate it. You can use it a bunch of times in the program. And this allows you to basically work with data throughout the duration of the program without having to explicitly define it every time. In programming, you're really working towards optimizing reusability, modularity, simplicity. So there's a few different data types that variables can have, or just numbers and things in general. So this right here is an integer, which is just a number, a whole number. You can have a floating point number. So that would be like 4.5 or even negative 4.5. You can have strings, which are just pieces of text. And you can have Boolean values. Boolean values are another type. Programmer equals true. So basically what Boolean values are, they're either true or false. They're 0 or 1. With all these data types, can be used differently throughout a program. So I'll show you guys some of the things that you can do with them. If you're ever unsure of what a data type is, what you can do is you can do type and then pass in whatever variable or data type you want into there, and it will actually print out whatever type it is. So you see this is a string, class string. If I do the programmer, it'll be class bool, short for Boolean. And all of these things you can actually convert between different types. So say I want to make this a float. Now, if I check the type of X, it's going to say a float. Whereas before, it's going to say an integer. And this isn't just exclusive to like different numbers that you can do. If it makes sense, you can convert most things. Like you can convert this string that's 10 into an integer as well by passing int on it. And then you can use it like an integer and do arithmetic with it and stuff. Now I'm going to be going over a little more detail into print statements, which you've already seen a bit with the print hello world example. And also, by the way, strings can be either single or double quotes. They just have to close with whatever they open with. This statement, a print statement, just puts whatever's inside of it to the console, whether it's a variable, whether it's a piece of text. The way print statements work is they write text to the console. If you just pass in a variable that is not a string, a piece of text, it will convert it to a piece of text. But you can't do something like this just by itself, where you're like, because that doesn't make any sense to it, because it doesn't know what it's talking about. If you write a comma here, though, it will automatically put a space between them and convert it to a string. With that, Python also has something called f strings. So what f strings are is they're a type of formatted string, in that you can write different expressions inside of here. So like I could write like 5 plus 5. And then what that's going to do is it's going to run whatever code is in here, or solve whatever's in here, or use a variable in here, and it's going to print it to the terminal. So the next thing in this section is input. So what does input do? Input allows you to get input from the user. So if we write a quick little example here of name equals input, what is your name? And then let's also, for the sake of this, replace this with this name value. So what this code is going to do is it's going to run this line first, ask what's your name, whatever name the user inputs, it's going to print hello, and then whatever that value is. So if I go here and I go Maximus, hello Maximus, you see? And if I run it again and do like Fry, hello Fry. This is one of the main ways that you actually interact with users in a program and allow them to do things. Now I'm going to be going over some of the basic like math operations. So say we have a value x of 5 and y of negative 4.5 again. Or let's do negative 7.2. Some of the things we can do are, I'm actually going to also, if you use triple quotes like this in Python, this is still a string, but it allows you to go over multiple lines. Single quote, if you do just one of these, it'll only allow you to do one line, but triple, you can do multiple. And I'm actually also going to make this a formatted string, which also formatted strings have a lot of extra properties to them that you can do. And I'll show you some of those. So x plus y equals, and what this in a formatted string is going to do is it's going to print out the result of this. We could also put it into a variable, but I'm just doing this just to showcase some of the things really quickly and to show you guys formatted strings better. So that's addition. X minus y equals x times y equals x divided by y equals x double divided by y equals, and I'll tell you what each of these are and what they're doing. Oops. Okay, so if we run this code now, we're going to get a lot of things printed out here. So this first one, if you use a plus operator in Python, what that does is it will add two numbers together. If you use it on strings, which I'll show you after this, it will combine the strings, but with numbers. it will add them together. And as you could see, this is a floating point. This is an integer. So you can add floating points and integers together, just any numbers together to add them. Use plus, subtract, minus, pretty simple. Multiply, use the asterisk. For regular division, just use a division sign. And this will divide them just regularly with a remainder. For floor division, use 2 of these, and this will only give you a whole number. So it will round it for you. Or it will tell you how many total times it can go into it. So 5 can go into negative 7.2 negative 1 times at most. What modulus is this is a remainder. So it's basically this this is how many times 5 can go into it. So 5, that would be 5.0 or negative 5.0 minus 2.2 would be 7.2. So this is how much is left after floor division. And this is a power. So in this case, it's 5 to the negative 7.2 power. Let me show you real quick how you can add strings together. You can add them into variables as well. I'm just printing them out to showcase things. So here's an example of hello space plus rolled, and it prints out hello rolled. Okay, so the next thing for this is comments, which will be on this file as well. So a comment is basically a piece of the program that you write that only people working on it can see. Only you can see, only other people who work on your code can see the program. It doesn't affect the actual logical flow of the program at all. In Python, a comment is the pound symbol. So you just do that and you can write some comments to yourself. The other way that you can write comments for multi-line comments, docstring comments, is like a multi-line string. You just don't assign it to anything. So if we run this, these aren't going to affect the program at all. They're just kind of notes for ourselves. And it's good for you to comment your code. You basically, while you're developing, you want to make your variables, which number 1, number 2, sum of numbers. You basically want to make your variable names as descriptive as possible, and anywhere where there's ambiguity on what you might have been trying to do, write some comments. So this is a lot better than just X and Y, because then it's clear what your code's trying to do. And this is for yourself, and when you're working with other people, when you're collaborating on a project, you want them to be able to understand what you're trying to do. So the next thing you're going to need to learn about in Python is data structures. And to start this out, I'm going to make a new file called list and tuple. Hold on, I accidentally didn't make it a Python file. And this file, basically, I'm going to be going over what lists and tuples are. So a list is a data structure that allows you to kind of hold multiple variables together. So here's an example of a list. Say you have a list like this containing a bunch of strings of names. This is one variable that holds multiple in it. This is the syntax for it. You set it equal to, and then you have square brackets in between, and you separate each item by a comma. You can also have different types inside of a list if you need to for whatever reason in Python. Most of the time you're going to be dealing with lists that contain one data type at a time, but they're able to have any different amount of data types in them. In order to access a certain element in a list, what you do is you call the variable, and then you have square brackets on the end, and then inside of here you pass in the index. Now lists start on index 0. So this element, it's the first element, like logically, Englishly, but in terms of Python, how Python sees it is this is element 0, element 1, element 2, element 3. So if we print out the 0th element in here, what this is going to print out is max, because it's the first item. Then 1 is going to give Fry. 2 is going to give Jason. 3 is going to give 0. And then if we print out number 4, this isn't in the list. It's going to give an error and tell you that the index is out of the list. A tuple is like a list, except for you use parentheses, and you can't change the values inside of a tuple after you assign it. So that's good for storing like different types of data that you'll never need to change. So I can show you. Actually, I forgot to show this before. You see, it doesn't allow you. It will say tuple does not support item assignment. However, if this is a list, this is actually how you can change values inside of a list. You just treat them as, you can think of this as a variable where each one of these indexes is like its own variable. You can access it the same way you can any other variables. This is just names 0, names 1, names 2. They're just kind of collected together with a little more functionality. But to change it, you just do this where you assign it, and I'll run this to show you. You see, it changed Max to Sam. So with this as well, if you want to get, say, like, there's a special syntax to slice a list, which basically means access certain parts of it. So it's like this. So each time there's a colon, it will go up until a certain point. So say you want the first 3 elements. You can go like this. First 3 elements. Or no, this isn't the first 3 elements. This would be the first 3 elements because this is the stop point. This is the start point. This is the stop point, and this is how many steps to take in between each one. So this, for example, first 3 elements. The first 2 elements, like this. And say we want like element 1 through 3. You go like that. And then what this step does, this last one, this is how many for example, every other one. So if I delete these, if you go like this will do every other item. So that, skip that, do that. And to add an element to a list, you use, which I also forgot before, my bad. You use .append. So here's an example of that, of adding will to it. So the next data type that we'll go over, here, let me make a new thing, is a dictionary. What a dictionary is it's like a list, but you get to assign kind of what the values are. So for example, say you want, here, let me just write out an example like this. This works basically like a list, except for instead of indexing this like 0, 1, 2, you're actually assigning what those keys are. So dictionaries have keys and values. This is a key, this is a value. Key, value. And the syntax is curly brackets and then key, colon, value. And then just like that, to access it, like you would in a list, you would go index 0, index 1. You just pass in whatever the key is. So here's my name. Here's my height. Here's the state I live in. You see, very simple like that. Another way you can access dictionary elements is with .get. In here, you pass whatever value you want to get. And then you can also, with this, pass a default value if it's not there. So for this example, it's going to print New Mexico. But say we want to check for my shoe size. It's going to check if that's in there. Since it's not, it's going to print not in dictionary. And this is generally the way you want to access elements if you can, because it allows you to save a lot of errors, and it's kind of a better practice. So for a dictionary, if you want to add something to it, what you do is you can go, like say I wanted to add shoe size. You go like this, and this will add it to it. As you can see, shoe size of 10 there. So now I'm going to be showing you what nested data structures are. So a nested data structure is a data structure inside of another one. So for example, here's a 3D list. You can also break lists and stuff into multiple lines like this. It makes it a lot more readable sometimes. You separate items with a comma, so this is basically a list of lists. Here, I'll just do 0, 1, 2, 3, 4, 5, 6, 7, 8. And why is this important? Well, certain data can be represented better like this. Like take, for example, an image. Say you have a picture. You can represent that as a three-dimensional list where each one of these is a value of the color of the pixel. And that's one way that you can represent images and work with images. And there's a lot of situations where you'll be using nested data structures like this because it makes representing certain types of data a lot easier. And then to print out or to access certain parts of this, you can go 3D list, and then the first element of this is this one, second, third. So say we want the first one, and then say we want to get this value, 0, 1, 2. So that would be 1. I missed a bracket. There we go. And then that'll print out 4. Basically, the way this works is the first element, 0, 1, is this list, and then the first element in that, 0, 1, is the 4. And that's how you print it out. And you can also assign these, append to these, treat these as the same. This basically gives you this list. And anything you could do with that list, if it was on its own, you can do it just with this syntax. You can index it, you can append to it, etc. And another thing that you can do to extend this is you can have a dictionary with lists inside of it. So say you have like a school, for example. Say you have grades, names, and ages or something. I don't know. You can set this up to have lists inside of here. So 100, 50, 74, 65. Names, Max, Will, Fry, Sam. Then ages 22, 20, 10, 19, something like that. So you can have a data structure here. And it's also worth noting, something I forgot to mention until this point, is that lists are ordered, dictionaries are not. So this order will always be the same. First item, second item, third item, fourth item. So you can give some meaning to that. For example, you can make it so like in an example like this item can always correspond to this, can always correspond to this. So if you query this, and I go, for example, print school grades 0, school ages 0, school names 0, 122 max. So that's the grade is 100, age is 22, name is max. And this allows you, basically data structures will allow you to represent different data different ways. So in this example, this is like a school system where you can see like people's grades, their names, their ages, any other data about them you can add to this. Okay, so now we're on to control flow. And to start this out, what control flow is, it's basically the way your program executes. So far we've just seen a program execute top to bottom, each line by line at a time. And there's actually different things you can do to make it so that your program does things depending on values of stuff, or loops over certain parts of code, or things like that. So first, I'm going to be reminding you guys what Booleans are, pretty much how they work. So say we wanted a Boolean for if someone was a student. Booleans are true or false, remember? So, and we also want a Boolean for if they are a computer science major. And we want one for if they are creative or something, just an example. So the way Booleans work is they're true or false, and there's different keywords that you can use to kind of work with them. So I'm going to put a print statement. So for example, is student and is CS major. So if and basically means if both of these are true, this will be true. So if I run this, true. Now if it is creative, so this is going to be false because one of them is false. So or basically means if one of them is true, then it will be true. If they're both false, like is creative, it will be false. Basically the opposite of and. And there's also not, which you'll want to know, which is like if they're not a student, which will just negate whatever this is. So if it's true, it'll be false, etc. And with those, what you can do is you can actually create a lot of complex logic and conditions based on a lot of things. So now going into conditionals, conditional statements basically allow your code to run different depending on certain values. So say we want to get a number from a user. Input, enter a number. Also, by the way, if you want to go to a new line on printing something out or inside of here, just \n. So say let's cast this into an integer, which we talked about in the start. So this will turn into an integer, ask them for a number. And then say that if the number is positive, we want to print the number is positive. If it's negative, we want to print it's negative. Otherwise, if it's 0, basically, we want to print that it's 0. So what we do is we can go number equals or it's greater than 0, print number is positive. This stands for else if. This will basically run if this is false. If this is true, this will run. If this is false, it will go here and then check this condition. Negative. This else basically is if everything's false up to that point, this will run. So now let me run this. Enter a number. Say we enter 10. Number is positive. Say we enter -5. Number is negative. Say we enter 0. Number is 0. And there's a few different things. If you want to do greater than or equals to, it's like this. So say you want to count 0 as positive in this example. Now if it's 0 or bigger, it will say it's positive. If you just want to check if it's equal to, you can do that with two equal things, and this equals a Boolean. This sets number equal to 0. This is a Boolean value. It will, if number is equal to 0, it will run that. So 0, for example. So that's basically how the basics of how conditional statements work. They allow you to run certain blocks depending on certain conditions. So next, I'm going to cover loops. So the main loop in Python is a for loop. Now, what does a for loop do? A for loop iterates over something and executes the code that many times, however many times the iterable thing does. So for example, if we want to make a list of numbers, numbers equals 5, 10, 20, 100, 50. What we can do is we can go for number in numbers, and this can be anything. This could be x, this could be x, num, etc. It doesn't really matter. That's just a placeholder value. What it's going to do is it's going to go through each item in numbers, and it's going to set that to this variable. And then whatever you do in here, it's going to run. So say we wanted to print them all out one by one, we can do this because it's going to go 5, num equals 5, print num. Num equals 10, print num. Num equals 20, print num. And this is really powerful because you can loop over things a certain amount of times or iterate through lists like this. So this gives you a lot of power. Say you want to print the square of every single number in the list. You can do this and it will print each one squared because it will num equals 5. Anything basically that num is assigned to, which is each of these values, will print here. Now, if you just want to loop for a certain amount of times, what you can do is you can do for I in range and then pass a value in here. Like 5, for example. So I will be the index or whatever you're at. Range 5 basically makes an iterable, which is like a kind of like a list. It's a little bit different, but Python treats it pretty similar, of numbers 0 to 5. Like stopping, not inclusive. So 0, 1, 2, 3, 4, for example. For the list, you could also use length, which is one of the built-in characteristics of numbers. And what this will do is it will get the length of this list, which is 5, and this will equate to 5, which will then go out here, and it will be for I in range of 5. And it should be the same thing. Now, a better way, if you need actually the index number of the list and the list to do it, is you can go enumerate numbers. And what this does is enumerate numbers. If we print it out real quick, is it will make an object, an enumerate object. It's basically a bunch of tuples with the index and then the value. So then what you can do is you can go for I, comma, x, print x, print I, comma, x, I guess. So now you can see the 0th element is 5, the first element is 10, etc. And this is like good, for example, if you want to find the index that like numbers that are positive are or something like that. This is how you would loop through it. All right, now we're on while loops. So what a while loop is it's a loop. It's kind of like a for loop, but it will continue to execute until the given condition is not true anymore. So say we have a value x that is equal to 10. We can do while x is greater than 5, print x. And you want to be careful with these because you need something inside of the while loop that will make it stop at some point. So in this case, its stopping condition is that x is less than 5. So we want to decrement x by 1. And we can do that a few different ways. We can do x equals x minus 1. But some ways that I didn't mention before is we can actually do x minus equals 1. And that will set it equal to itself minus 1. It's just a little shortcut that Python has. So if we run this, it will print 10, 9, 8, 7, 6, and then it's 5. So this is no longer true. Another thing you can use these for is you can set it to just while true, and this will just keep looping. Then inside of here, you can do something like get input. Enter your name or Q to quit. Set this to a variable. And then print out like. And then what you can do is you can do if name is Q, which you told them to enter if it quits. You can do something called break. And what break does is it will break out of whatever the loop you're currently in is. So let me hold on. There we go. So if I run this, you see it will ask for your name, Max, hello Max, enter your name, hello Fry, enter your name, hello Will. And then if I type Q, it will go into this segment and break out of it. So similar to break, there's also a special kind of keyword called continue, which actually let me do elif. What continue does is, let me just set it to 0 right now, is it will restart the loop onto the next iteration. Actually, a better way to do this would be for I in range 10, print I. And then what we can do is we can do if I is 5, continue. And what this is going to do is once I equals 5, it's going to restart the loop, so it's never going to print it. It's just from here going to jump to here. So if we run this, you see 1, 2, 3, 4, 5 is never printed out. And with these, you can kind of do a lot of things with looping through things, and it might take some practice, but you can get used to it pretty quickly. And with this, a lot of the times you might want to like create a list, for example. And this is actually the next section. Hold on, let me actually copy this and I'll make a new file for comprehensions.py. So a lot of times you'll want to make a list, and one common way to do that is to loop through a for or a while loop like this and append things to a list. So for example, instead of writing the first, say you want the first 100 numbers, instead of writing 0, 1, 2, 3, 4, 5, 6, 7 through 99, you can do this. And you'll be tempted to do this. So you see there's now it has all the numbers 0 through 99. And say you want all the numbers squared 0 through 99. You can do that too really easily. But there's actually an easier built-in way to do this. So for example, what you do is you go you go an expression here. So let's do x squared as our expression for x in then some iterable. So this is the same thing as what we saw just before, and this is preferred when you can. If you're just thinking through it logically, you can do it the other way because it's a little easier, but this will, let me actually print this out. Oops. So you can actually do it this way as well, and it will make your code look a lot cleaner. And similarly, that I forgot to mention until now, if you want to iterate through a dictionary, me equals, let me actually go to the dictionary section. So what you can do to iterate through the dictionary is you can go for key. So you can do this to iterate through the keys, and then dot values. You could do dot values to get the values, I believe, if you would like. Instead, never mind. Dot value. There you go. So if you want to get the values, do dot value. If, hold on, let me remove this print statement so it's a little easier. If you want keys, don't do dot values, and then we'll go through the keys, and you can kind of access things that way as well if you want to go through them or do something to all the different things in a dictionary. All right, so next I'm going to be going over code structure. So what is code structure? Well, it's basically the way you structure your code. First, I'm going to start with functions. What functions are is they're kind of like mini blocks of programs. that you can define certain functionality in and reuse multiple times within the same program. I'm just closing up some files real quick. So the way you actually create a function is you do def, short for define. Say you want to subtract numbers. You take an x and y. These are the parameters. These you define. These are basically just like variables. When you're calling it, you'll pass these in. They'll get set to these variables, and you use these inside of the function. So for this, return, what return does is it will give that value back. So for example, like when you call length of a list, len, list, the return value of that built-in function is however many items are inside of that list. So for this, we'll just do a simple example, x minus y. So now if we call this 10, 5, it's going to set x to 10, y to 5, and it's going to return this. And say we wanted to keep subtracting different stuff. 105, 15. So if we run these, you see it's going to subtract each time. And this is very useful because you can make your code really modular and separate functionality and make it so that it's really powerful, because you might have some complex logic in here that you need to do. And then instead of writing that code a bunch of times, you just write it once and then call it every time. And with this, with functions, they also allow you to create modules and packages. So say, for example, I want to use the subtract numbers inside of another file. Where did example go? Oh, here it is. Subtract numbers. Where is it? No, I need to go from, what did I call it? Functions, import, subtract numbers. You can actually do that like this from whatever the file name is, import this, and then you can use that code in other modules. So for example, print subtract numbers 5, 10. And then if I run this, hold on. Oh, hold on. You want to be careful when you're doing this because it will run the whole file. So you don't want those there. I'll show you in a second kind of how you can avoid that. But if we go back here, run this, it's going to do -5. So let me run it again, -5. You see, so you can call it in different files. What I was saying before is what you usually want to do when you're writing code is you want to have this this kind of code structure here. Let me make sure that I did this right. Yeah. So you want something like this here. And what this is basically telling the computer, if __ name equals __ main, it's basically telling it that if the user runs this file, execute this block of code. If they run it directly, if they call it from a different file, don't. So this is a good habit to have when you're writing code. Then a lot of times people will write a main function, which they put their functionality in. And then they just run it like this. So there you go, -5. So another thing with these modules, Python has a certain amount of built-in modules. So one example of these is math. You can import the math module, and if you want to import specific things, you can go from math, import, and then like square root, for example. And with this, it just adds more functionality to your program. So the math module has a lot of different mathematical functions you could do: sine, cosine, tangent, etc., square root, like we imported here. And square root, for example, allows you to get the square root of something. Another common one is random. And specifically randint is used a lot. So if I run this, it will do, hold on. It needs to have stuff between stuff. A random number between 0 and 10. So each time it's going to print out a different random number. So if you want to use randomness, you can use that. And this allows you to add a lot of functionality to your program. And when you want to use things that are in the standard library, or you can also install packages with pip. So for example, you can go like pip install numpy is a popular one. And what that's going to do is it's going to download numpy, which is a package someone else made online, and install it into your Python so you can use its functionality for other things. So for example, from numpy import numpy as np. So what this is going to do is it's going to assign it as np. So every time you use it, you can go np dot, and here's in Visual Studio Code, you can see some of the things that are in it. Some of these are similar to like math and stuff, but there's a lot of things. Basically what numpy is it allows you to do a lot better vector math and a lot of high-end kind of functionality on that. And it's used a lot in machine learning and data science. So let me find one that's a good example. Array. And then how does this work? You can usually read how things work here. I think you just pass in a list, if I remember. I haven't used NumPy in a while. But basically the point of this section is that you can and you see it will represent as a NumPy array, which has a lot more quick mathematical operations. Basically the main point here is that you can import these other modules externally or the built-in ones to Python into your programs in order to have more functionality, so you don't have to do a lot of stuff, so you can focus on writing the code you need to write. So the next thing we're going to be covering really briefly is file IO. There's two main different types of file IO you'll really want to know right off the bat with Python. The first one is just reading and writing to general files. And the second one is reading and writing from CSVs, specifically with dictionaries, I would say. So the basic syntax for writing to files, and this will actually create the file if it doesn't exist already, is you do with open file.txt, whatever the file name is here. And then here you do W. As you can see, it's giving a lot of different modes in here that exist, but W as F, print, or f.write. Here, we'll do the hello world. If I could type. So when I run this, it's going to create this file and it's going to write here. If this file exists already, it's going to overwrite everything inside of it. So you want to be kind of careful with this. And it will also automatically close the file if you do it this way. So if I run this, you see it create a file.txt that says hello world in it. Another mode is append mode. What append mode will do is it will actually allow you to add to a file. So file.txt exists. I do this, append new line, hello world. If I open this, you see it added a new line, and I could just keep running this. And files are really important because they allow you to save data between times you run a program. So usually when you're writing code in a program, it only exists as long as that program's running. If you use a file, you can kind of use it like a database in order to save data in between uses. So there's also the last main mode of file writing is read mode. And the main things you'll do is read or read lines, I would say. So what read does is it will read out the whole file. Let me actually print it out. I misspelled print. and it will make an object. Or hold on, there we go. You need the parentheses there, and it will actually add the whole contents of the file into there. If you want to separate the lines, which is useful a lot in things, you can do f.readlines. And this will make a list where each item is a new line in the list or a new line in the file. That's all for this video. Thank you guys for watching. I'm actually going to be working on building out more expanded versions for each of these concepts and showing them more in depth, and then improving on this this 1 hour course over time, doing this every so often where I condense things better and teach things a little bit better. Thank you guys if you stayed to the end. If you want to learn more, again, join the community, top link of the description. Subscribe, like. Thank you guys. See you guys next time.